the complex conjugate roots theorem. I need you to take the notes, pause the video and take all the notes. The complex conjugate root theorem states that if we have a polynomial in one variable and a plus bi is a root, then its complex conjugate, a minus bi, is also a root. We have to understand the term conjugate. So what does it mean? Here I have an example. Solve x squared plus 6x plus 13 equals 0. I use quadratic formula to solve this equation, and at the very end I got the answer -3 plus or minus 2i. So what does it mean? It means I have two roots. The first root is -3 plus 2i. The second root is -3 minus 2i. These are complex conjugates. If you look here, you see that the sign in front of the imaginary part changes. -3 stays exactly the same, but in the first root we have -3 plus 2i. In the second root we have -3 minus 2i. These zeros, these two roots, are complex conjugates. Now, how do we use the theorem? So what does it do? We can write the conjugate of a given complex root, and after that we are going to turn both into factors, and after that we are going to come up with the original polynomial, what we did before. But before I was asking you to write down a missing root. Now I'm not going to use the word missing root. I would say write the conjugates of a given complex root. Okay, so I'm going to start with the first example. I need to practice how to write a conjugate of a given zero, which means a conjugate of a given root. Let's say the root that is given to me, and it has to be imaginary root, right? It's given to me as 3 minus 2i. What is the conjugate to this root? It has to be 3 plus 2i. Let's say I have -3 minus 2i. So what is the conjugate to this root? -3 plus 2i. Let's say the complex root that is given to me is 5 minus 3i over 3. What is the conjugate to this one? 5 plus 3i over 3. Okay, let's do more. The given root is 5 plus 7i. What is the conjugate to this root? 5 minus 7i. The given root is -1 minus 6i. What is the conjugate to this root? -1 plus 6i. In other words, all we did, just write the conjugate to the given root. My next example is a polynomial has the following roots. find the additional zeros using conjugate roots theorem. Alright, my first example. Example 1. Let's say I have following zeros like 5, comma, 1 minus 3i. This is all that is given to me. I will be asked to write down a polynomial using the zeros that are given to me. Well, I cannot do anything because something is missing here. I know that I got this 1 minus 3i imaginary root. Imaginary roots require conjugates. Now I'm using a new term. In other words, something is missing, the root is missing. So which root is missing? I'm going to write it down here. Missing one. The missing 1 plus 3i. Did I answer all the questions? I was supposed to find additional zeros using the conjugate roots theorem. Yes. Do I need to come up with the original polynomial using these 3 roots? No, not yet. I have more examples. We need to find all additional zeros using complex conjugates theorem. Let's say what's given to us is -5, and then I have 5 plus 6i. This is all I have. I need to find all additional zeros. I know that I cannot have additional +5 because it's not an imaginary number. But 5 plus 6i is imaginary, which means needs a partner, needs a conjugate. This one needs 5 minus 6i. Next one. -4, +3, and now I have -3 minus 7i. This is all that's given to me. I need to find additional zeros. I may not have additional 0 for -4. It's not an imaginary number. I may not have additional 0 for +3. It's not an imaginary number. But -3 minus 7i is an imaginary number. I must add a conjugate. -3 plus 7i. Let's say I have something with square roots. One root is 5. Next root is 1 minus √3. 5 does not require conjugate. Impossible. 1 minus √3 is not imaginary, but it has a square root. Because of that, I may write down the conjugate. Conjugate is 1 plus √3. Okay, let's have one more. Next example, I have 1 minus 3i given to me, and I also have 2 plus √5. Do I have conjugates for both? Yes. The conjugate for 1 minus 3i will be 1 plus 3i. Would I have a conjugate for 2 plus 5, √5? Yes, and it's going to be 2 minus √5. This is the conjugate, and that is a conjugate.